Right. Welcome to the Manhattan GMAT Study Hall. This is the March 18th, 2010 edition. Today's agenda, again, quick sound check. I know we did this about 5 minutes ago, but smiley face icon, which is over there, go ahead and click on the smiley face if you guys can hear me. Okay, sound check successful. All right, so what we're going to do is today's main topic is inequality workshop, but the first thing I want to do is a brief word about what sorts of questions should you submit and what sorts of questions should you not submit. Okay, let's talk about that. So we're going to lay down a couple of guidelines here for question submissions. Guidelines for question submissions. The basic underlying deal here, okay, as you know, you may or may not know, but remember on the Thursdays with Ron webpage, there's a form on which you can submit questions. The first rule that is absolutely a rule here is that you can't submit prohibited sources. Okay, the first rule is that anything that is a banned source on the forums is also a banned source here. Any source that's not okay on the forums is not okay in the study hall either. Most notably, this includes the OG and OG supplements. You're not allowed to submit official guide problems for this study hall. The rationale behind this policy is that this is a free study hall that's literally open to anybody who wants to attend it, and the OG is a paid source. It's the same reason that we're not allowed to use OG on the forums. Okay, students in our paid classes can use the OG as much as they want, precisely because we require that all of our students purchase the OG. But in the context of the forums and study hall and any other free events, it is not a fair use of their copyrighted material under fair use doctrines for us to do the OG. So if you submit OG problems, that's not a valid submission. Okay, if you don't know which sources are banned and which sources are not banned, for a list of banned sources, check the forums. If any of you don't know where the forums are, it's www.manhattangmat.com/forums, and check the top post in the general verbal or general math folder. There you'll have a list of banned sources. Okay, and as long as we're at it, there's like rule number 1A, which is that if you're going to submit specific questions, you need to actually tell us what the source is. You need to specify the source. Okay, if you don't, and if you're extremely lucky, then we'll probably know the source. Because a lot of these problems, we know exactly where they're from, because we've seen them many times over. On the other hand, if you give us a question that we haven't seen, or which is from an unknown source, then we don't know if we're stepping on any copyright toes. So we don't know if we are making ourselves liable to any sort of copyright legal action, and believe me, there's a lot of that in this market. So you've got to tell us where the problems are coming from, otherwise we can't legally use them in a study hall. Okay, so smiley faces if you guys understand these guidelines. I know a lot of you haven't submitted any problems, but if you're going to, please acknowledge that you understand them. Okay, thank you. Now, as far as questions that you do have, as far as the scope of the questions, there's a few other things that I want to make you aware of. I mean, remember the first thing you've got to understand, is that there are a very high number of questions being submitted. I mean, as you can imagine, there are about 50 or 60 people registered for tonight's event. And believe it or not, a lot of the questions are submitted by people who aren't even registered for the event. So, we get large numbers of questions in the first place. So therefore, we can afford to have some pretty strict guidelines about the questions that are submitted. But scope of the questions, rule number 2, don't submit questions that are so general that it's impossible to answer them in a session. Okay, let me give you an example of one of these questions. One of today's question submissions was the following. Let me give you 2 examples. One person submitted the following question: please explain complex geometry. I mean, this really doesn't, this is not something that we could hope to acknowledge in a one-session study hall. I mean, complex geometry has tons and tons of aspects, and there are so many things that this could mean. I mean, what kinds of problems is it? Coordinate geometry, maybe area problems, algebraic geometry problems. I mean, there's so many geometry problems. I mean, we have a geometry strategy guide, which is approximately 150 pages long for this exact reason. So there's too much. I mean, you can't give something that's so sweeping. And then, I mean, one person even submitted something like this. One person actually submitted, please explain what the official guide doesn't explain. Guys, this is an absolutely impossible request. I mean, we have no idea what this means. When you say what the official guide doesn't explain, you could be asking me anything from how to choose the right wine to go with your steak, all the way to a few obscure properties of equations. So these are not meaningful questions, and they're not something that I can answer. So, I mean, I'm not trying to belittle the people who sent these questions in. If any of you are here right now, please don't take this the wrong way. But imagine that you are in our shoes and you receive a question of this sort. This is not the type of thing that we can address in class. 2 more rules as far as the scope of the questions. Rule number 3, don't submit questions of a personal nature. Now, I mean, that doesn't, when I say personal nature, that sounds like we're Ann Landers, we're in a Vice column. That's not what I mean. What I mean by a personal nature is don't submit questions that don't pertain in any way to the group. We actually get a lot of this. We get something like, I have quant score X and verbal score Y. My goal scores are Z. I want to apply to school A, etc. The problem with questions like this is that these are intensely personal questions. This is a study hall for which our attendance ranges from, about 25 to 40 people. And so if we have a question like this from one person, we are addressing about 1/40th of our population. This is not a good thing. So there's a place and time for questions like this. That's the forums. Okay. If you have questions like this, there is a place for you to take those questions, ask on the general folder, general questions folder on the forum. That's actually the purpose of the general folder, is to accept problems like that. So, and those questions are addressed by me and also by Stacy Coprince, who's one of our other staff instructors who also has a big duty on the forum. So these are the kinds of questions that they're not inappropriate questions, but they're inappropriate for a study hall because this is a group context and we want to make sure this is relevant to all of the people who attend. Final rule is this is a little bit more subtle, but because we have a large number of questions to choose from, remember the goal of the study hall. The goal of the study hall is to have a theme, or at least a couple of themes that are somewhat continuous. So don't submit questions that are so specific that they can't yield any general lessons. For instance, one type of question that's not really appropriate for a study hall is specific questions about like one particular idiom in some sentence correction problem. You know, the best place to post things like that is the forums again. And for these things, this is more appropriate for the forums. Because that's what the forums are for. The forums are for questions of that nature. So the golden mean here, all right, so now that we have all the don'ts, these are all the don'ts. What we're going to get to in a second is the do's. Okay, but does everybody smiling face if you guys understand what we're talking about here? Okay. You know, and then also, like I said at the beginning of this little unit, even if your question does fit within the bounds of the submission guidelines, we can't possibly answer all of the questions that people submit because we probably get about 5 times as many questions at least as we can address in the study hall. We have pretty high volume here. So just FYI. Now one more slide of what should you submit. So now you've seen the don'ts. Now, what sorts of questions should you submit? Okay. The ideal question, because if you notice, these two guidelines may seem a little bit contradictory. We're telling you rule number 2 is we don't want questions that are too general. Rule number 4 is we don't want questions that are too specific. So, because the really, really specific forums are, I mean, any question that, let's put it this way. Any question we can answer in like under a minute doesn't belong in the study hall. It belongs in the forums because we can answer that in one post on a thread, and then we're good. Okay, so here's the deal. The purpose of the study hall, the purpose of these study halls is to present topics in cohesive themes. Okay, so what this means, therefore, the ideal submission is specific enough that we can address it in one session, but not so specific that we could just answer it in a minute or two. So the ideal submission has specific nature but also general questions. For instance, here's one of the submissions that we got a few months ago that gave rise to, we had a problem about comma ing modifiers. You know, student gives example problem and cites the source. So what that's going to look like, people usually quote a question. It doesn't, you don't have to have a question, but there's a question of some sort, and then there's answers. Okay. Then the student asks a question that pertains to the problem, but then generalizes the question somewhat. So something like a student could, on a problem like this, could ask something like, how do I decide between the modifiers in choices like B and D? But then it's not just that. They also ask questions like, in general, how do I use comma plus ing modifiers? Or, what are the rules for using, the pronoun which, etc. So these are generalizable questions that can afford us themes. Okay, these are specific enough that it's not something, some people submit us questions that are like, please explain sentence correction. Not going to happen. Please explain sentence correction could be 500 hours. So, but you guys can see where we're going with this. This is also not, if the only question were this one, this would be a forum topic. Because this is one problem, but when you ask a general question like this one, it's more like, okay, this is a good topic. So if you remember, if you were here for a study hall, I think it was a couple months ago, we did comma ing modifiers. We had a whole theme on that sort of modifiers. So that's where we're at. When you submit questions, you should try to adhere to these guidelines as much as possible so that we can have study halls that are not just random collections of problems. All right, give me a smiling face if you guys understand where we're at with that, and then we'll move on. Start talking about inequalities. So today's topic, inequality workshop. We are going to be looking at various types of inequalities, and again, this is from student submissions. We had students submit questions like, they gave me a specific inequality, but they were also like, what do we do about inequalities that look like this? What do we do with inequalities with denominators, etc.? So it's pretty ambitious. I've got about 10 problems on the slides. We're going to try to move through them pretty quickly. If we don't get to do them all, then we will spill them over into a later edition of the study hall, either the one in 2 weeks or the one in approximately 4 weeks. Please don't move things on the board. Thank you. In fact, I think I'm going to just disable people's ability to write on the board because we don't really need that. Okay. Let's look at the first set of questions. But before we do this, a quick review of inequalities in general, the basic fact about inequalities. Basic facts. So this is probably going to be review for a lot of you who are here, but let's just make sure we're starting off on the same page. Most manipulations are the same as they are for equations. But there's one major exception. Does anybody want to type in this text box over here what that exception is? Stuff to do with negative signs. Okay, so the one exception, the major difference, is that if you divide an inequality by a negative number on both sides, then you have to flip the alligator. Let me explain what I mean by an alligator. When I was in second grade, the way they taught us inequalities, here's a really basic inequality. 3 is less than 5. The way they taught us this in second grade, because second graders can't really reliably have the spatial sense to discriminate between a less than sign and a greater than sign. So the way that they taught us that in second grade, and this is what explains the alligator on the front of today's lesson, is they taught us that this was an alligator, and it was a hungry alligator. And so since it was hungry, it always ate the bigger number. All right, so this is what we mean by an alligator. So I know it seems a little bit facetious right now, but there's an important reason why I'm doing this. So from now on, when I say alligator, this refers to less thans, greater thans, less than or equal to's, and greater than or equal to. Those from now on are going to be called alligators. Because I don't want to use the word sign, because I'm going to use the sign to refer to plus and minus. So this is just to prevent confusion, because otherwise if I say sign, you're not going to know whether I mean pluses and minuses or whether I mean alligators. Okay, so quick smiley face on the smiley face icon if you guys understand what I mean between alligators and signs. Okay, so if you, by the way, the other face, if I ask for a smiley face at any point, the other face that's underneath it is what you can click on if you're ever lost. Okay, so a quick example of an inequality manipulation. Let's say you have something like 11 minus 3x equals -7, is less than -7. First step you can do to this inequality is like normal. You can subtract 11 from both sides. That doesn't flip the alligator. So this is just -3x, and this is just -18. But then your next step is division by -3. So we all know what happens. We have to flip the alligator. So once you do that stuff, you've got yourself an x, you've got yourself a 6, but now your alligator is facing the other way. So this is all pretty basic. Smiley faces if you're with this. This is a big, major difference between inequalities and equations. All right, so let's move on to a more substantial problem. Go ahead and try your hand at these data sufficiency problems. I'm going to actually cover up the second one for the time being, and I'm going to give you a countdown clock. Here's the way this is going to work. If this is the first study hall for any of you, up there, unfortunately I actually don't have an arrow to point up there with, but way up at the top left of the screen, there are buttons that say A, B, C, D, and E. Okay, those are how I want you to answer this question. Do not, and I'm going to hide your answers from your fellow students, so no one else is going to be able to see your answer. So there's no reason to be shy about answering the question. But remember to answer with the buttons at the top left. Do not answer in the text box. Thank you. Okay, I'm going to give you a timer with about 1 minute and 40 seconds. This is a pretty short problem. So have a good time. Please, again, do not answer in the text box. There are buttons up there that you can click at the top left of your screen. Okay, that's the time. Please, if you have not answered the question, go ahead and answer it. Standard talk, if you attended my study halls, you've definitely heard this talk before, but on the real GMAT, you have to answer all the questions, and you have to answer them in a decent amount of time. So everybody, please answer the question, even if you have absolutely no clue what is happening. Please give an answer of some sort. So 5 seconds. If you need to finish up, give me an answer. Okay, here are the answers that you guys gave. Here's your answers. So notice we have pretty much a deadlock between B and D. It turns out that D, which is the most popular answer, is not the correct answer to the question. So let's talk about why, and remember we've got some learning to do here. This The correct answer to this problem is B, like boy. Let's go ahead and find out why. Here's the story, okay? If you picked D, you probably thought there's a such thing as cancel. Okay, there is not, so hold on 2 seconds here. I'm going to take this stuff and move it to another slide. Okay, so we're going to put an explanation for this problem over here on the right-hand side of the box. Okay, some takeaways here that we'll put these in the right-hand side of the box. The other we can call it in a second. Okay, first of all, there's no such thing as canceling. Canceling is a fake operation. There's really no such thing as just crossing stuff out in an equation or inequality. Okay, and every time you cancel something, you're doing some sort of legitimate mathematical operation. Every instance of canceling is either addition, subtraction, multiplication, or division. And you've got to figure out which one is especially important with inequalities, because remember we have this rule about the alligator. Because if canceling is multiplication or division, then it's going to affect your fortunes here, whether you're dividing or multiplying by something that's negative. So let's take a look at statement 1. Let's make our grid up here, if those of you who are familiar with the grid. Give me quick smiley faces if you know what this grid is. I know most of you are veterans of this. If you don't know what this grid is, then give me the other face. If you do know what it is, then give me the smiley face. Okay, so this looks like it's pretty much universal. I see one face of somebody who doesn't know what the grid is. So that one person, this is, okay, I see 2 of them. Most people here know what this grid is. For those of you who don't, this is a grid that streamlines your progress through the data sufficiency problems. The A and the D are the questions for which statement 1 is sufficient, and the B and the C and the E are the questions for which it's not. So basically this is a process of elimination chart. If statement 1 is sufficient, then these are the only answers left, and if statement 1 is not sufficient, then these are the only answers left. If you want, so those of you who gave me the first face, that's the basics. If that makes sense to you at least, then give me the other face. Give me the smiley face. And if you'd like, okay, good. I'm seeing it from one of you guys. If you'd like more information on that, you can watch the recording of the first class in which we explain this in detail, or you can check out our guides. Okay. Take a look at statement 1. Statement 1 starts out with xy is greater than y squared. Please type in the text box, what operation are you doing to this in order to produce x and y? You have to do division, right? In this case, there's no such thing as canceling a y. I mean, because remember, canceling is not a real operation. You have to figure out, if you think you're canceling stuff, here you want to cancel y. But in this case, that's division. So what you're doing, and with inequalities, it is absolutely imperative that you figure this stuff out. What you're trying to do here is you're trying to divide by y on both sides. So we know capital Y. Ooh, I did not mean to do that. Okay, well, we're trying to divide by y on both sides. If you do that, then you do get an x over here and you do get a y, but where's the problem? Text box if you guys understand. Yeah, remember the rule, and see, like, this is how the GMAT, this is how they roll. Like, it takes very basic rules that all of you understand, such as this one, but they give you problems that test those rules in very clever ways. This is why you can't just memorize rules. This is why you have to get takeaways from problems. Because we don't know if this is positive or negative. I mean, you're probably used to just doing algebra with actual numbers. But that's not what's happening in this case. In this case, we're trying to divide by something whose sign we don't know. We don't know the sign of y. So this is a big fat question mark. Question mark is less than if y is positive, but it's greater than if y is negative. Sorry, that's backwards. If y is positive, then you don't flip the sign. You don't flip the alligator, sorry. And if y is negative, you do flip the alligator. So we don't know which way this goes. This is a yes or no question. If y is positive, this will be a yes to the question. If y is negative, this will be a no to the question. So that's insufficient. So this one, A and D are out. Everybody give me a smiley face if you follow this argument. Give me the other face if you're lost. Okay, I'll look for majority of smileys here. So I'm especially looking at you guys who picked D because there's a lot of you. Okay. So let's get a takeaway from this. The takeaway is you cannot divide or multiply an inequality by an unknown unless you know the sign of that unknown. Remember, sign means plus or minus. Doesn't mean alligator. It just means you can't do it at all, which is kind of frustrating. Because with equations, as long as we know y is not 0, we can do this. But not unless we know the sign. With statement 2, on the other hand, it's a little bit of a different story. With statement 2, we've got xy squared is greater than y cubed. Text box, please. What operation are we doing to get down to x and y out of this stuff? Remember, you can't call it canceling. You have to call it division. Good. So here we need to cancel, quote unquote, i.e. divide by y squared. Now, we know that y squared is not negative because that's impossible. Stupid question, is it possible for y squared to be 0? Because if y squared could be 0, then this would be a big problem. So text box, if you guys have any input on that. Yeah, I see some of you typing. It's impossible for, y squared is also not 0. Because the statement wouldn't be true. So notice that this statement can't be a lie. If y is 0, this would be a lie because 0 is not greater than 0. So therefore, we can actually do division here by y squared because we know that it is definitely positive. So divide by y squared on the top, divide by y squared on the bottom. We know that these quantities are definitely positive. So let me write that out. Definitely positive. So therefore, this means that x is definitely greater than y, and so this is sufficient. Because there are other questions, there have been questions that depend on your not forgetting about 0. Okay, it turns out not to matter here, but when you do things based on signs, don't forget about 0. I mean, 0 is kind of like a third sign, in addition to positive and negative. Because you've got zero's got very different properties than do either positive or negative number. So when you look at number properties and when you deal with this kind of stuff, there are a lot of cases where 0 is an exceptional case to the rules for either positive or negative number. So, and that goes for inequalities and equations. So this is a very important takeaway. We could probably even have an entire study hall on the properties of 0, but it's not where we're at right now. So any questions about this problem, smiley face if you understand all of this, and if you're ready to move on. Smiley faces. Okay, I see lots of smiling faces. By the way, I know those of you who've seen my study halls before, we've seen this sort of emphasis, but these kinds of takeaways are the only reason ultimately why you are studying at all. The only purpose of doing any sort of practice questions, I know we've beaten this to death in prior editions of the study hall, is to get takeaways that you can apply to other questions. And I've also addressed this in other study halls as well, but for those of you who are new, I'll go ahead and recap it. None of you should concern yourselves pretty much the least bit with difficulty levels of the question. They don't really matter at all. In fact, there are several good reasons why being concerned with difficulty levels is actually a bad thing. I'll give you the quick rundown of that. Again, there's some chatter in the text box about difficulty levels. If you guys are even trying to classify this as a number difficulty level, your priorities are totally in the wrong place. The reason why is because these lessons that you learn don't depend on how hard the problem is. You can very easily learn takeaways from easier problems that will take down harder problems. And if you start classifying problems according to difficulty, then you're going to start isolating them. I mean, you're going to start thinking of so-called 600-level problems as totally separate from so-called 700-level problems. That's the exact opposite of effective studying. I mean, you're looking for connections between problems and lessons to draw from problems, absolutely regardless of their difficulty level. So I mean, just be aware of that. If you are even thinking about difficulty levels, you have exactly the wrong priorities. Big deal. You should only be concerned with what you can learn from the problem. All right, let's move on. Try your hand at this problem. I'll give you another timer. I'll give you about 1:45 or 2 minutes, and I'll clear out your answers. Remember, again, please indicate your answer in the top left of the screen, not the text box. Here's a timer. Have fun. Okay, there's a lot of you without answers here. Try to answer in the next 15 seconds, please, maybe the next 10 seconds. And we'll get started. I see the question in the text box. I'll go ahead and answer that one in a second. So we are definitely all over the place on this one, so feel free to guess. I'm waiting for guesses from a James and a Christina. Go ahead and indicate something, please. And a Margaret. There's also a Margaret who hasn't answered the question. Okay. Waiting on James and Margaret. 3, 2, 1. Give me something if you're here. All right. Here are the statistics from the problem. As you can see, we are all over the place. So there are at least 3 extremely popular answers, which are A, C, and E. So let's see where we can go with this. Those of you who thought the answer was A, I'm not going to tell you whether you're right or not yet. But if you thought this statement was sufficient, what operation were you trying to do? Text box. If anyone's got an answer for me. Like if you thought, yeah, there it is in the text box. Cross multiply. Okay, I'm going to break you guys' heart again here. Notice I just broke your heart on the last slide. Because I told you a lot of you believed in canceling your whole lives, and then you come here tonight and I shatter your hearts by telling you there's no such thing as canceling. Well, I'm about to shatter whatever hearts you have left even more, because I'm also going to tell you there is no such thing as cross-multiplying. I mean, you guys didn't really think there was, right? You guys didn't really think there was some magic voodoo multiplication that lets you multiply across an inequality alligator, right? You didn't think that. Or an equal sign. So let's talk about what that really is. Because with equations, you can get away with it. But with inequalities, it's a disaster. It's a total fake operation. So like if you had an equal sign, let's talk about what's really going on here. If you have A over B equals C over D, then you actually can get AD equals BC. Does anybody know how this really works? Okay, I noticed one person actually put it in the text box already. What cross-multiply really is its multiplication by the product of the 2 denominators. Product of the 2 denominators. That's what you're really doing. This is really multiplying by the product of B and D. Because then if you look at what happens, notice I'm not going to use the word cancel because we just had a warning about that. But well, what's happening here is you divide out the B's on the left side. That's out of there. And then once you multiply by BD, the D's divide out on the other side. So that's what you are left with is AD equals BC, but this is what you're actually doing. So one person asked a question about how do we know that B and D are non-zero? Yes, you do, because another takeaway is that you're restricted. When you're given a statement is restricted to when you're given a statement like this. When you're given a statement, the statement is restricted to those values for which it is actually true and possible. Okay, so for instance, therefore, anything in a denominator can be safely assumed to be non-zero. So that's the answer to the question that someone posted a little while ago in the text box. Because again, if B and D were 0, these statements would not be possible because they wouldn't mean anything in the first place. Like you can't have division by 0. So I mean, in most GMAT problems, they will explicitly just go ahead and tell you that B and D are non-zero. But if you have this sort of thing, at least in statement 1, you know that B and D are not 0. And in statement 2, you know that D is not 0. Because you can't put a 0 in a denominator. And they do have a disclaimer, by the way, that tells you that. They do say that you're restricted to real numbers for which the statement has a meaning. So any questions so far? All right, now, if you take our course, if you have questions, again, feel free to type them in the text box. That's the best way to integrate your questions with the flow of the class here. The easier statement is number 2. Okay, remember to solve the easy statement first. This is a topic with which we deal in our 9-session course, but if you have a statement that's visibly easier than the other one, then you should deal with it first. So in this case, that means we want to deal with statement 2 first because it's clearly much easier to deal with than statement 1 is. So let's use this grid. If you've taken our course, you'll know there's a grid that deals with statement 2 first. That's got BD on the top and ACE on the bottom. Okay, let's do statement 2. Statement 2, yeah, we have absolutely, I mean, what does this mean? Notice that B over D greater than 0 means that B and D have the same sign, i.e. both positive or both negative. But that's all we know. There's definitely not enough here to make a judgment. So this is not sufficient. All right, smiley face if you guys understand that. Nobody said B, but there were 2 of you who said D. So D would imply that this statement alone would solve the problem. So the 2 of you who picked D, I want to make sure you give me the smiley face here because this thing is not going to solve the problem. Okay, so that's going to rule out B and D. Statement 1, remember that you absolutely cannot just cross multiply. There's no such thing. So remember that cross multiply is an imaginary, it's a fake operation. It doesn't really exist. You can't really do that. And your explanation of what cross multiply really is over here on the other side. So, what are we actually trying to do? Tell me in the text box. See a few of you typing, so I'll wait until you type in the text box. You are trying to get an AD and a BC, so you're trying to cross multiply. No, this doesn't mean that all 4 have the same sign. In fact, this is an inequality, so that wouldn't make any sense. There's all kinds of ways this could work out. Because, you know, it's an inequality. There's a lot of freedom here. You could have 2 positives, you could have a positive and a negative, or you could have 2 negatives, and let alone the individual possibilities. So you don't want to be thinking about all 4 individual signs just because there's too much to think about. I mean, you couldn't treat all those possibilities. But no, I mean, we're trying to cross multiply. So cross multiply is not real. So what we have to try to do is what cross multiply really is, which is we have to multiply by BD. I mean, you know, we can at least try that. So if we multiply by not just D, because if you do just D, you're going to have a B still hanging out down there. So you want to try to multiply by both denominators. If you do that, then that will give you an AD on this side, and that will give you a BC on this side. But the problem is, again, we don't know what the alligator is. Because if BD is positive, then that's still going to be a greater than sign. But if BD is negative, then that's a less than sign. And as far as the yes or no question goes, that's this would be a yes to the question. This would be a no to the question. So now, I think whoever is typing in the text box, you're a little bit ahead of us. You're using both statements together. So now that's what we have to do. Because statement 1 is not sufficient by itself either. So now let's try them together. And let's see what happens. Well, you're doing the same thing. Now, if we have B over D is greater than 0 from statement 2, then we know that B and D are both positive or both negative. Notice the quantity with which we are concerned is BD. We don't care about individually B or individually D because that's not what we care about. What we care about is the product. But if this is the case, we know that BD is positive. So this is a really, really important takeaway that we're going to put over here in the takeaways section on the left-hand side. Okay, all 3 of the following statements are exactly equivalent. B over D is positive. B and D have the same sign. And B times D is positive. And then there's also the reverse of these, which we don't deal with in this question, but if this says negative, and this says negative, and this says different signs, then those are also equivalent. So let me write that over there on the other side. There you go. So again, the question is, there's a question in the text box, how do you know that B and D are positive? We don't know that, and we don't have to. Because remember, we don't need these individually to be positive. All we need is that is the product BD itself. This is actually a major theme of session number 4 of our 9-session class. If you have a combination of more than one variable, then all you care about is the overall combination. I mean, if B and D are individually negative, it doesn't make any difference. Because this statement tells us, as we wrote down here, telling you that the quotient is positive is actually the same thing as telling you that the product is positive. So once we have that, we can multiply by this, and we leave the alligator unchanged. So we can multiply by BD and keep the alligator. So AD is greater than BC. Sufficient. This is not an easy question. As you can see here, this is one of our potential CAT problems. This is going to go into our pool. It's not in there yet. It's a development question that I wrote. It's meant to be a harder question, but again, it doesn't really matter how hard or easy it is. It matters what you learn from it. And all of these lessons that are over here on the left-hand side of the board you can get from this one problem. It's pretty cool. All right, any questions before we move on to something else in the realm of inequalities? Okay. Let's see one of you typing in the text box. So I'll see what you guys type. Okay. Just one other person typing. One other person typing. Yeah, these are recorded. Yeah, this is going to be on a recording. It'll be posted on the website by, I think, Monday is how they usually do it. So, okay. The next question we're going to look at is actually not an inequality, but the takeaways are relevant to other inequalities. So let's take a look at it. The next question is right here. Again, this is not an inequality, but the lessons we're going to learn pertain to other inequalities. So not an inequality, but the lessons do pertain to inequalities. Okay, give it a shot. Here's a timer. Go for it. For the person who wants the recordings in the text box, I just put the address in the text box. You can click that. Okay, I didn't clear your answers out from last time. So if you have not updated your answer to reflect the answer to this question, please do. Give you about 5 or 10 more seconds to do that. Yeah. All right, let me give you the statistics for this problem. It looks like everybody's got an answer except for like one person who just showed up. So here are your statistics. And it turns out the consensus answer to this problem is actually wrong. The answer to the problem is not B. So, or sorry, the answer to the problem is not C. Even though C is the most popular answer choice, C is incorrect. So it looks like we're going to do some learning here. The correct answer is B, so pardon my, I misspoke there. So if you had B, don't stress out. Let's take a look. All right, here is the story. I'll run through this really quickly so that we can hit some other inequality-related problems. But let's define variables. Since there's no relationship at first, this is one of the few problems on which you should actually define two variables. If you guys have been watching my earlier study halls, I did a study hall once on when you do multiple choice questions, you should almost never use two variables. But in the case of data sufficiency, you'll have to more often because there are a lot of problems where there's not really a relationship at first. So let's let X be the number of 23-cent pencils. Sorry, it's supposed to say 23-cent pencils. And then let's let Y be the number of 21-cent pencils. So in this case, the equation for number 1 is just X plus Y equals 6. And the equation for number 2 is 23x plus 21y equals 130. Okay, if you have trouble setting those equations up, then you can consult our strategy guide in Word translations, which will give you some help on how to set that kind of stuff up. But in this case, there's an additional restriction which kind of spoils the game here. All right, but first let me tell you what you don't want to do here. Okay. Do not assume that you can just use rules of thumb. Okay, if you see this problem and think, oh hey, two equations in two variables, I need them both. you will get it wrong. And this will happen a lot. Because if you, okay, well, one thing you guys have got to know is that one of the main purposes of a standardized test is to differentiate people who think critically about problems from people who just memorize stuff. And so there are a lot of problems written with the explicit purpose of trapping people who just memorize stuff. So the basic rule that you want to have in mind is don't just trust rules of thumb. Like if something has exceptions, then don't use it. That's basically the rule. Don't trust things that have any exceptions. So for example, the Pythagorean theorem doesn't have any exceptions. If I have a right triangle, then leg squared plus leg squared is always equal to the hypotenuse squared. So that I can use. On the other hand, this rule has plenty of exceptions. There are at least 3 or 4 ways in which this rule can fall apart. So don't use it, just pretty much period. And then that's the rule. You know, and also get takeaways about the problems on which it falls apart. But in this case, there's additional restrictions on the answer to this problem. There's an additional restriction on what kind of numbers x and y can be. Who knows what that restriction is? Text box. Yeah, they've got to be integers and they've got to be non-negative. So, because these are numbers of pencils. Okay, so here's another takeaway. On word problems, you need to look for implied restrictions on the numbers. This is a big deal. You can't have 2.4 pencils. So we need to have, and you can't have -3 pencils either. So we need to have a non-negative integer number. So that's the key, really, to the problem here. So there's one more takeaway, but you got to realize the restrictions on the problem. In this problem, x and y must be non-negative integers. And believe me, this is gonna matter. Okay, on problems with restrictions, if you don't get the restriction, you are gonna get it wrong. I promise you. I mean, I'll lay money on the table on that one. If you solve problems ignoring restrictions, you'll get them wrong. So with this in mind, statement 1 is the easier statement. So let's make a grid. Let's put our grid up here in the corner. AD. And this slide is getting a little bit crowded. So sorry about that. Statement 1, this is still insufficient because Marta could buy any combination of 6 pencils. So, like, you know, each of which costs, so she could buy 0 and 6, 1 and 5, 2 and 4, etc. So this is insufficient. So we can cross off A and D. How do we solve number 2? Does anybody know? Go ahead and type in the text box. See a couple of you guys typing. How do you solve equations if the only thing you can do is have an integer? It turns out, yeah, a couple of you are saying plug and choose, backsolve. Backsolve is if you, some other company uses that word, I think it's a good Princeton Review or Kaplan. The only thing you can do, this is your final really, really important takeaway here, if a problem is restricted to whole numbers, then algebra will be totally unable to distinguish those from non-whole numbers. Okay, you'll have to test values. There's no such thing as algebra that differentiates between whole numbers and non-whole numbers. So I mean, this is an example of a problem that you just literally won't be able to do with algebra. It's not going to work. So just be aware of that. So in statement 2, the only thing we can do is try values. Just try numbers and see what happens. So we need 23x plus 21y to be 130. Someone's saying it's hard to test all values in 2 minutes. It's really not. There's not a lot of possibility. So it's hard if you don't start doing it pretty soon. But it's not. If you have questions, please go ahead and type them into the text box rather than doing the hand raise thing. Thanks. The question in the text box, you can't use that equation. Can't you use? No, you can't, because you can't substitute unless you have both statements. The equation that's posted in the text box is what you get if you substitute this into here. We're not there yet. Well, we're not dealing with both statements. We're just dealing with the second equation. So you don't, this is basic data sufficiency technique, you don't use them both unless they're individually insufficient. So what you do is you just try the numbers, okay? You don't need to think about common divisors, you don't need to do any crazy algebra, you don't need to do any of this stuff. You just say, okay, 23x could be 20, it could be 0, it could be 23, it could be 46, it could be 69, it could be 92, or it could be 115. Those are the only multiples of 23 that are less than 130. If you have those, then you can subtract to figure out what 21y is supposed to be. 21y would have to be 130 in this case. It would have to be 107 in this case. It would have to be, in this case, 84. In this case, 61. In this case, 38. And in this case, 15. So notice that what we're doing is we're just taking away from, hold on. Line these up a little bit better. Okay, what we're doing is you just subtract from 130 cents to figure this out. Well, these, again, 21y has to be some multiple of 21. So if you get things that are not multiples of 21, they're not valid solutions. And again, algebra is not going to tell you that. 130 is not a multiple of 21, neither is 107, neither is 61, neither is 38, neither is 15. So you get one answer that works. It's pretty crazy stuff. But that's the only valid possibility. One valid possibility. We need 46 cents, so we need 2 f for x, and 84 cents out of 21, so that's 4 for y. So that's sufficient. So the answer is B. Question in the text box says, can you factor 130? You could, but there'd be no point in doing that because you have things that add up to 130, and if something is the sum of 2 or more things, there's not really any good reason to factor it. Factoring is only for products, not sums. So lots of takeaways here. If any of you are addicted to doing algebra, then you're really going to not like what I'm saying here, but that doesn't make it any less true. If you have a restriction where your solutions have to be whole numbers, then ultimately the only thing you can do in cases like this is to test numbers and see what happens. So there's questions here about common divisors. You don't need to think about that stuff. It's too complicated. There are things you can do with common divisors, but they're really advanced number theory, and the most recent thing posted in the text box is actually totally incorrect. We don't know that statement 1 is true. We don't know that. This is statement 2 only. So the way in which this lesson pertains to inequalities is that this is also true when you have inequalities. If you have a whole number restriction on a problem, then you're going to have to just test a bunch of numbers and not do algebra. So that goes for inequalities as well. So we're going to move on here pretty soon. Are we good here? Give me a smiley face. Even if this problem frustrates you, give me a smiley face if you understand the takeaways that we derived from it. Okay. These are big. These are really important. About this, you can't just trust random rules of thumb. And you also need to look out for restrictions on problems. This problem is from the official GMAT Prep software. This is not a Manhattan problem. GMAT Prep, by the way, you guys can feel free to submit GMAT Prep problems because those are freely distributed software. So there's no copyright issues with submitting those. All right, let's move on. Here's another one. Okay, so try this. Give this a shot. Okay, this is another GMAT Prep problem, by the way. I'm noticing the curious irony of the fact that the people who are posting and saying that GMAT Prep is really easy are the people who are not necessarily getting the problems right. So you may want to refrain from making comments about this is easy or that is easy. In general, that's just it's not good form. Don't do that. It's kind of rude, actually. So let's we're all here to learn stuff, basically, is what I'm getting at here. So you've got answers. Please indicate answers in the next 10 or 15 seconds. Remember, you have buttons in the top left corner of your screen on which you can click and indicate an answer, please. Okay. Not an easy problem. We've got the class is doing better than they did in the last problem. Okay, everybody's got an answer, so let me show you the statistics. Here's the one person listed as no answer is me, so you guys have all answered the question. That's a good thing. C and E here are popular answers. Let's take a look. So again, this is with inequalities, but there's a common thread with the last problem, and I hope that the last lesson helped you out here a little bit. We've got to have whole numbers again. So let's just put that restriction up front. Again, we are, well, that's big font. And again, we are restricted to whole numbers. So we may wind up testing numbers again, especially with the combination of these statements. But let's go ahead and define. Let's say that H is the number of hardcover books. And let's say that P is the number of paperback books. Then you're given that the total cost, you're given that the paperback books are $8 each, and the hardback books are $25. And the question asks you, what is H? So, and basically, statement 1 is telling you that the problem statement tells you that P is greater than 10. And that's actually all that that really tells you. P is 10, and then nothing about H. Statement 1 tells you that they cost 25 each. So statement 1 tells you that 25H is greater than 150. You can divide that by 25, and that gives you that H is at least 6. I need to put some lines on that, so hold on. At least means greater than or equal to, so that's fixed. Okay, smiley face, if you follow that, the total cost of the hardcover books is 25 times H. So H is at least 6. And then the total cost of all the books that Juan bought was less than 260. So this is 8 times P plus 25 times H. It's less than 260. Okay, so statement 1, if you get these inequalities written down, if you successfully translate these, then you can conclude somewhat quickly that statement 1 is not sufficient. All we know is that H is at least 6, so this is insufficient. There's no maximum on H at all here. If you have this statement, then H could be 6, it could be 75,000. We have no idea how big H is. So if you pick this statement as sufficient, make sure you reconsider. Any questions about this statement, go ahead and type them in the text box. But this is not going to be sufficient. So we can cross out A and D. Statement 2, let's take a look. Statement 2 tells you that Statement 2 tells you that, sorry, font size mess up. We know that 8P plus 25H is less than 260, and we know that P is at least 10. P is greater than 10. So there are some inequality manipulations that you can do. In fact, I'm going to show you 2 ways to do this. One way is just plug in numbers. And one way is make sure you know how to manipulate the inequalities. So let me show you each of those. Plug in numbers and manipulate the inequalities. Okay, if you plug in numbers, we know P is greater than 10. So let's try P is 11. Then we know that 88 plus 25H is less than 260. Take 88 away, that gives us 25H is less than 260 minus 88, which is 172. So we know that H is 25 goes into 156 times. This is 6 point something. So what we've learned here is that, because this time we don't know that H is at least 6. So H could be 1, 2, 3, 4, or 5, or 6 here. So if P is 11, then H could be anything from 1 to 6. So that's insufficient. I'm manipulating the inequalities. I'll show you, this is actually going to wind up being, this has been an incredibly fast time progression. We're going to be running up against the end of this study hall here in a second. But I'll give you a rule that we're then going to continue into our next math study hall, which may be next time or the time after that. There's a rule that states that you can combine, if you like doing algebra, then here you can do this. You can combine inequalities by adding if they have the same alligator. So what we need to do, these alligators right now are not the same, but if we multiply this by -8, then we can make them the same and we can cancel the P. So this one we won't touch, but we can multiply the other one by -8. And that'll give us -8P. That'll flip the alligator, and then we can add. So that'll give us 25H is less than 180. Notice, now see, there's a problem here, which is that this is a better way to do it. This is not guaranteed to be all possible solutions, because this ignores the fact that we're dealing with integers here. So, because of the restriction. In other words, I mean, this does have to be true. Let me try to explain this as best I can. This does have to be true, but it may not cover all the possibilities. I mean, it may not be restrictive enough, is actually the best way to put it. And this is the, and in fact, here's a case in point. If you do this, you're going to think H could be 7, but it turns out H actually can't be 7. So in this case, algebra not only doesn't really work, it actually gives you the wrong indication. So then if you picked E because of this, take note. So you shouldn't do this. You should plug in numbers because of this restriction. So the question in the text box, the answer is because of this. When you have a restriction to nothing but whole numbers, you should just plug in cases and not try to do too much manipulation of inequalities. So this is still insufficient, but let's go ahead and work with them together. This is, where did this come from? This came from multiplying that by -8. The purpose of multiplying by -8 was to switch the alligator around so that we could add them, and to cancel the AP. If we multiply this by -8, then this will go away, as it did here. So, well, we just multiplied this whole thing by the number -8. All right, let's do this together. I've got a little bit of room left on the slide. Pardon for the crowding. Let's try them together. Well, okay. One observation you want to make here is that the more paperback books you buy, the fewer hardcover books you can buy. Okay, so I mean, we know that P is greater than 10, and we know that H is at least 6. So let me make that a true statement by adding a line here. Here's your line. Okay. Again, it's just like here. If a problem is restricted to whole numbers, you've really got to approach it by testing values. It's like we said down here. So let's do that. Let's try P equals 11 first. This is the same analysis that we had before. Let's do it. 88 plus 25H is less than 260. 25H is less than 172. H is less than 6 point whatever. The only H that does this now is 6. That's the only H that'll work if H is less than 6 point something. So that means in this case, H is 6 only. Now there's two things we can do here. You can either try more P's or observe that if I buy even more paperbacks, then I'll be able to buy fewer hardbacks. So I'll tell you what will happen. We're actually over time already, so we're going to have to cut this off here because I've actually got obligations to attend to. But I'll tell you what happens. What happens is if you plug in 12, you'll still find that H can only be 6. If you plug in 13, you will still find that H can only be 6. And if you plug in 14 or more, then there will be no H's at all that work. So you may want to try those. Remember, you got to obey these restrictions and see that. But you'll notice the pattern. Or you can observe. Remember, you have a fixed ceiling on how much money you can spend. You have a $260 limit. So what this means is that the more paperbacks you buy, the less hardbacks you can buy. You're already restricted to 6. Anything under 6 is no good. So if you realize that pattern, then you don't have to do any more plugins. You can realize this is the absolute maximum that you'll get. So let me type that in words. What's happening here? Okay. In other words, this H equals 6 is the maximum number of hardbacks because increasing P, because P is at a minimum. There's even more takeaways here for you guys. Another valid takeaway here is if I want to maximize H, I minimize P because there's a trade-off. So this is a complicated problem, but it turns out then the answer is C, because if you have the two statements together, the only valid value for H is 6. And you can verify that by either plugging in more numbers or making this observation. But the main takeaway here, without getting too obsessed with this particular problem, the main takeaway is the same thing that it is here. If you have a whole number restriction, then algebra is not terribly useful, and at worst, it's pernicious. So that's an important fact. Okay, hold on just a second here. what we're going to have to do, unfortunately, we're going to have to close this. We're already over, and I've got other appointments to attend to here. So, you don't, by the way, the 2-minute thing, you don't have to solve these things in exactly 2 minutes. You can take up to 245, 250, something like that, because, I mean, you're not, you don't have to solve everything in under 2. You're going to have some problems that you solve much faster. So taking an extra 30, 45 seconds is okay. And on problems like this, you'll have plenty of reason to. All right, it's been fun. Any super quick questions? We can. Some of the study halls are verbal, some of them are quant. So the next study hall will probably have a verbal focus. And I mean, note there's also a archive of previous ones if you've missed any of those. Yeah, if you want to talk about timing strategy, you can submit that as a question. Remember, the form is at that web address. It's at the top. Scroll up to the top of the text box and look for the web address. It's near the top. So, and then you can submit that. Actually, sorry, it's in the middle of the text box. If you scroll up to the middle of the text box, there's that web address, the Thursdays with Ron page. That's where you can submit the problems. Okay. We're going to have to close here. We are over time, so please you can just quit out of the program, and if you, okay, yeah, so if you want to just, Andrew, go ahead and just submit that again as a question in the study hall page, in the Thursday with Ron page, where it says submit questions. Go ahead and submit that, please, and then that'll put it higher on the priority list. Okay, so you can just quit out of the program. You don't have to click any logouts or anything like that. You can just leave. If you don't, in the next minute or two, I'll start logging you guys out, and I hope you have a good night, and I hope you've enjoyed the program.